In this lesson, we are going to look at partial fraction with a quadratic factor denominator. Now, in our previous lesson, we looked at the linear factor denominator, which we said that for the linear factor, the highest number of degree must be 1. So an expression like this is a linear factor. We can also have something like 3x minus 2, and this goes on. For a quadratic factor, we can have an expression like s squared minus 4, and here we can also have s squared minus 2x plus 1. We can also have an expression like 5s squared minus 7. So all this expression here is a quadratic factor. Now we see that for a linear factor, the denominator with a linear factor, which we, for example, if we have x plus 1 divided by x minus 2 times x plus 3. For the numerator, we have a constant a all over x minus 2 plus b all over x plus 3. For a quadratic factor, the numerator of a quadratic factor is given to be bx plus c. So if we have expression like with x plus 1 all over x times s squared plus 3, this expression, this is a linear factor, so we are going to have a all over x plus the quadratic factor, which would be, remember that this bx plus c is for the numerator, that's the constant value for a quadratic factor. So this will be all over s squared plus 3. So let's take an illustrative example and see how we can find the value of a and b and c. We have a question: 4 all divided by x plus 1 times 2x squared plus x plus 3. We can split this fraction or decompose this fraction into this expression a all over the x plus 1, which is for the linear factor, and plus b. Okay, so this will be bx plus c, which is for the quadratic factor, and this will be 2x squared plus x plus 3. So now if we take this expression 4 all over x plus 1 times 2x squared plus x plus 3, then this is the common denominator multiplied by the x plus 1 times 2x squared plus x plus 3. We notice that this expression entirely is gone, so for the left hand side we are left with 4 equals to, now if we take the same expression, multiply it by the term a all over x plus 1, notice that x plus 1 is gone, so we are basically left with a times 2x squared plus x plus 3. And if the same thing is being multiplied by this term bx plus c all over 2x squared plus x plus 3, this is gone, and we are going to be left with bx plus c times x plus 1. So let's think of a value of x that can eliminate one of the terms. If x equals to minus 1, this expression will be gone. So let's say when x equals to minus 1, we are going to have 4 equals to a into bracket 2 times minus 1 all square plus x, plus minus 1 plus 3 plus b times minus 1 plus c times minus 1 plus 1. Okay, so let's see here. This is going to give us 2 minus 1 plus 3. Here we are going to have 0, and this will be minus b plus c. So let's simplify this. 2 minus 1 is positive 1, and positive 1 plus 3 will give us positive 4. So what we are left here is 4 equals to 4a, and therefore the value of a will be equals to 1. When dividing through by 4, we are going to have positive 1. Then the next thing we are going to look at is to find for b and c. Okay, now we are going to expand this expression. So this is going to be 4 equals to, take a multiplied by all the terms inside the bracket. So this will give us 2as squared plus the term here ax plus 3a. For the bx times x, this will give us plus bx squared plus bx, and c times x will give us plus cx plus c. So when you expand this bracket, this is what we are going to arrive at. Now let's group like terms. So grouping like terms, we are going to have 4 equals to, into bracket, 2a plus b times s squared plus a plus b plus c times x. So this is what we are grouping. This is ax, bx, and cx. Now, and what we are left with is 3a plus c. Okay, so first we are going to equate this to their coefficient, corresponding coefficient. So at the left hand side here, the value of s squared is 0. So it means that 2a plus b is equals to 0. So let's call this expression equation 1. Also, in this expression, we are having here to be a plus b plus c also equals to 0. So the coefficient of x at the left hand side is 0. So let's call this equation 2. Also, we have 3a plus c equals to 4 is a constant 4. All right, so let's see what we can do with this information. Now we can say that from equation 1, okay, from equation 1 we know the value of a, right? So we can say that b is equals to minus 2, because when you substitute the value of b, the value of a into this expression, we are going to have b equals to minus 2. And in this expression, so we are solving for c, we also save from equation 3, this is equation 3. Okay, we can say that, let's see, from equation 3, 3a plus c is equals to 4. So it means that c will be equals to 4 minus 3a, and the value of a is 1. So this will be 3, and so c is equals to positive 1. Now from what we have found, a equals to positive 1, b is equals to minus 2, and c is also equals to positive 1. Now from the given expression, we have that 4 all divided by x plus 1 times 2x squared plus x plus 3 was to be expressed, or can be expressed as a all over x plus 1 plus bx plus c all over 2x squared plus x plus 3. So now we are going to substitute the value of a, b, c into the expression. So it means that this is what we are going to have: 4 all divided by x plus 1 times 2x squared plus x plus 3, and this will be equals to, the value of a is 1, so this will be 1 over x plus 1, and this will be plus the value of b is minus 2, so I prefer bringing that of C first since we have positive, so this will be 1 minus 2x all over 2x squared plus x plus 3. So this is how we go about this question. Let's 5x squared minus 4 all divided by x squared times x plus 2. Now let's decompose this expression. So this is going to give us, first we need to know which of them is the linear factor and the quadratic factor. X squared is the quadratic factor and this is the linear factor. So we are going to say that this is a all over x plus 2 plus b x plus c all divided by x squared. Recall, for the numerator, this expression is the factor for the numerator. Okay, now if we go ahead and multiply this term by the common denominator, at the left hand side we are going to have 5x squared minus 4 equals to, for the term a we are going to have a x squared. For the term bx plus c we are going to have x plus 2. So let's think what we can do. If we eliminate this expression, we can find a, right? So let's take a equals to let's take x equals to minus 2. So when the x take the value of minus 2, we are going to have 5 times minus 2 all square minus 4 equals to a, and this will be minus 2 all square plus bx times minus 2 plus c, and this will be minus 2 plus 2. So this expression here is going to give us 0, and whatever is left here is going to be minus 2b plus c, and we know that 0 multiplied by any number is 0. So here is going to give us 4a, and here we are going to have 5 times 4, because this was going to be positive 4, this will be 20 minus 4, which is going to give us 16. So what we are left with in this expression is 16 equals to 4a, and solving for a is going to be equals to 16 divided by 4, which is equals to 4. So that is the value of a. Now for b, we are going to expand the expression. Expanding this expression, we are going to have 5x squared minus 4 equals to ax squared plus bx times s, this is going to be x squared plus 2bx plus c x plus 2c. So let's group like terms. So this will be 5x squared minus 4 equals to, so we have this term s squared. So this is going to be a plus b times s squared plus the term x, so this will be 2b plus c times x plus 2c. So we can say that, let's see, okay, a plus b is equals to 5, equating their coefficient. So the coefficient of s squared at the left hand side is 5. We call this equation 1. And let's see, the coefficient of x at the left hand side is 0. So basically we say that 2b plus c is equals to 0, and we can call this 2. Also we see that 2c will be equals to minus 4. So we can easily find the value of c by dividing through by 2. So this is going to be divided by 2 divided by 2. So the value of c here is minus 2. Alright, so we have found the value of a to be equals to positive 4, that of c to be equals to minus 2. Let's see. Okay, so from equation 1, say from equation 1, we have here a plus b equals to 5. So this is going to be that b is going to be equals to 5 minus a. We found a to be 4, so this will be 5 minus 4. Then the value of b is going to be positive 1. So here we have b to be equals to positive 1. So here we are going to rewrite the expression. It was given to be 5s squared minus 4 all divided by s squared times x plus 2, which can be expressed as a all over x plus 2, which for the linear factor, plus bx plus c, which is for the quadratic factor. So substituting the value of a, b, and c. Recall we find a to be positive 4 and b to be positive 1 and c we have here to be minus 2. So c is given to be minus 2. So in this expression we are going to say that 5s squared minus 4 all divided by s squared times x plus 2 is equals to the value of a is 4 all over x plus 2 plus that of b, which is 1. So 1 times x is x, so we have x, and c is minus, so this is minus 2 all divided by s squared. So this is going to be the expression for this fraction. So what I want you to do is pause the video, write down the question, and split this fraction or decompose this fraction into partial fraction and find the right answer and see if you will arrive at this expression. In the next section, we are going to look at partial fraction with repeated root.